Today I am continue to the engineering mathematics second. Now, today I am discuss the new topic Fourier series. What's about the Fourier series? This is the third unit of the engineering mathematics second convergence and series. First of all, I am discussed the Fourier series. The Fourier series. What is the known? What you can know about the periodic function or periodic time? First of all, you can note down the periodic function. First of all, you can note down periodic function. Periodic function. First of all, I am discuss the periodic function. If the ft is a function of periodic function, then the interval between the ft and ft plus capital T and other and so on is equal, then you can call the periodic function. First of all, I am discuss the periodic function. You can note down if the ordinate of ft is equal intervals like ft is equal to f t plus capital T is equal to f t plus 2t and so on where t is a period. T is a period of time. This is known as a periodic function. There is the main periodic function of like trigonometric function sine, cos, sec, and cosec is 2 pi, and period of the tan and cot is pi. You can note down. For example, the period of sine theta, cos theta, sec theta, and cosec theta is 2 pi. You can note down this is 2 pi, and the period of, or you can say the periodic time, period of tan theta and cot theta is pi. You can simply write, or you can solve some examples of related to sine, cos, sec, and tan theta is a time period. You can say case number first. If sine 2x, you can write sine 2x plus 2 pi or equal to so on. You can write the periodic time of sine 2x is sine 2 is a common x plus pi. Now you can say the periodic time of this is equal to pi. You can say pi. Now again is sine 5x. You can say sine 5x plus 2 pi, or is so on. You can write sine 5 is common. You can write x plus 2 pi by 5, or the periodic time of this is equal to 2 pi by 5. Now similarly, cos sec and cosec is also. And you can case number second. This is very important for your examination. If tan 5x, you can write tan 5x plus pi is equal to, and so on. You can write tan 5x plus pi by 5. The period of the time is equal, called periodic time, is equal to pi by 5. Pi by 5. This is very important. First of all, you can note down to this function. If you have any problem, please comment to my videos. This is a periodic function. If the time period of all the functions is equal to g is equal, then you can call the periodic. This is a periodic function. If the any series is a time period will be equal. Now first of all, you can note down if the sine and cosine and their angles in multiple form is known as Fourier series. We know that it means a naught by 2 plus summation n equal to 1 to infinite an cos nx plus summation n equal to 1 to infinite bn sin nx. This form of the series is called the Fourier series, or you can write the expansion form of this series is equal to a naught by 2 plus a1 cos x plus a2 cos 2x plus dot 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 and so on plus an cos nx plus b1 sin x plus b2 sin 2x plus and so on plus bn sin nx. This is called the Fourier series where a naught is equal to DC component of electric work and a1 comma b1 is component to find the frequency of the electric circuit. Frequency of circuit. This is known as a Fourier series. You can learn this series is a Fourier series. If the sine and cos and their angles in a multiple form is known as a Fourier series, like a naught by 2 plus n equal to 1 summation n equal to 1 to infinite an cos nx plus summation n equal to 1 to infinite bn sin nx. And this is the expansion form of the Fourier series. Now, first of all, to find, or you can note down the topic, determination of components. First component is to find a naught. What is the value of a naught? Now let fx is equal to, you can note down, fx is equal to a naught by 2 plus a1 cos x plus a2 cos 2x plus dot plus and so on plus an cos nx plus b1 sin x plus b2 sin 2x plus plus you can say plus bn sin nx. This is equation number first. Is a Fourier series. Now taking integral of this function, integrate equation first at x is equal to 0 to 2 pi, 0 to 2 pi, you can write we get integration 0 to 2 pi fx dx is equal to, you can write integration of 0 to 2 pi a naught by 2 dx plus integration 0 to 2 pi a1 cos x plus a2 cos 2x plus an cos nx into dx plus integration 0 to 2 pi b1 sin x plus b2 sin 2x plus dot plus bn sin nx dx. Now this integration will be 0, since if the limit is 0 to 2 pi and this is 0 to pi and this integration also equal to 0. Now you can write integration 0 to 2 pi fx dx is equal to integration 0 to 2 pi a naught by 2 dx, or you can say a naught by 2 into 2 pi minus 0, or you can write this is equal to a naught into pi, or you can simply say a naught is equal to 1 by pi integration 0 to 2 pi fx into dx. This is a value of first component a naught. This is a value of first component a naught. If you have any problem related to this integration, please comments to my video and you can solve this integration and this is integration. You can solve this is a even function. Now this integration will be 0. Now first of all note down this component's value of a naught. Now I am continuing to find the component a n and b n. Now I am continuing this step to find a n. Now multiply cos nx in equation first with integrate both sides at interval x is equal to 0 to 2 pi. You can multiply the equation first. This is a Fourier series. Now you can write integration 0 to 2 pi fx cos nx dx is equal to you can write a naught by 2 integration 0 to 2 pi cos nx dx. Now again you can write plus integration 0 to 2 pi 0 to 2 pi, you can multiply of a1 a1 cos x plus a2 cos 2x plus dot 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 plus an cos nx and multiply of cos nx dx plus integration of 0 to 2 pi b1 sin x plus b2 sin 2x plus and so on plus bn sin nx cos nx into dx. Now you can write integration of 0 to 2 pi fx into cos nx dx is equal to, you can write an by 2 integration 0 to 2 pi cos nx dx plus integration 0 to 2 pi a1 cos x plus a2 cos 2x plus dot dot plus cos nx dx plus integration 0 to 2 pi cos square nx dx plus integration 0 to 2 pi b1 sin x plus b2 sin 2x plus bn sin nx and multiply of cos nx dx. Cos nx dx. Now this integration and this integration and this integration, the value of this integration is equal to 0 and you can write integration 0 to 2 pi fx into cos nx dx is equal to integration of 0 to 2 pi, sorry, an, this is an cos square nx dx. All the value of integration will be 0, only this integration is not equal to 0. Now first of all you can note down, now I am continuing this step. Now you can write integration 0 to 2 pi fx into cos nx dx is equal to integration 0 to 2 pi an cos square nx into dx. Now integrate of this function is equal to integrate 0 to 2 pi fx cos nx dx is equal to an into pi. an into pi. Now the value of an is equal to 1 upon pi integration 0 to 2 pi fx into cos nx dx. This is a value of component an. This is a value of component an. This is a value of component an. Similarly, to find bn, the value of bn multiply multiple of equation first sin nx and integrate both sides, integrate both sides at x is equal to 0 to 2 pi. Now find the value of bn. Bn is equal to 1 upon pi integration 0 to 2 pi fx into sin nx into dx. This is the value of component bn. This is the value of component pn. Now you can find similar of value of pn. If you have any problem, please comment to my video. First of all, you can note down this is a basic of the Fourier series. Now I am discussing the related some numerical to these topics. This is clear about the numerical problems. If you have learned the main components value of a naught, an and bn, the periodic, the use of the Fourier series is basically used in the electric circuit problem, solve the electric circuit problems. Now this is a very important for the periodic time function. The Fourier series is mainly depend on the periodic times. Periodic times, if the equal intervals find between the both of the function, or you can call the synoidal function. You can call the synoidal function is called the Fourier series. Is called the Fourier series. This is the wave equation problem. I am solving to this numerical problem related to the Fourier series. Now you can note down the solution of this problem. We have fx is equal to x plus x square at minus pi is less than x is less than pi. Then find the value of a naught. A naught is equal to 1 upon pi integration minus pi to pi fx into dx. Put the value of fx, you can write pi minus pi to pi x plus x square into dx. Now solving this problem, 1 by pi bracket integration of this function is equal to x square by 2 plus x to the power 3 upon 3 minus pi to pi. Put the limit of minus pi to pi, you can write 1 upon pi bracket, you can write pi square by 2 plus pi cube upon 3 minus, put the value of minus pi, you can write pi square by 2 minus pi power 3 upon 3. Now you can find the value of a naught is equal to 1 by pi into, solve this problem, you can write 2 pi cube upon 3. Now the value of a naught is equal to 2 pi square by 3. This is the value of a naught. Now again find the value of an. Find the value of an. This is a naught and this is a naught. An is equal to 1 by pi integration minus pi to pi fx into cos nx dx. Put the value of fx, you can write 1 by pi integration minus pi to pi. Put the value fx x plus x square cos nx dx. Now integrate of this function, you can write 1 upon pi bracket. First of all, put the value of this x plus x square and integration of this function, you can write sin nx upon n. Now again minus differential of this function, this means 1 plus 2x and integration of this function, this is minus minus plus cos nx upon n square. Now again minus differential of this function, this means 2 into integration of this means sine nx upon n cube and limit minus pi to pi. Now put the limit of minus pi to pi, you can write 1 upon pi. If the limit pi to pi put in this function, the sine function will be 0. Now the limit is putting 2 pi plus 1 cos pi x upon n square minus 2 pi plus 1 upon n square into cos minus pi x. Now you solve this problem. This is an is equal to 1 by pi. To solve this function, you can write 4 pi upon n square cos nx. Now you can simply write an is equal to 4 upon n square minus 1 to the power n. This is the value of nth term of an. Now you find n equal to 1, 2, 3 and dot dot. Put the value of a1 is equal to, put the value of 1. This means 4 upon 1 square minus 1. This means minus 4 upon n square. Now simply the value of a2, put the n is equal to 2, you can write 4 upon 2 to the power 2 and the value of a3 is equal to minus 4 upon 3 to the power 2, comma, and so on, and so on. First of all, you can note down this numerical problem and find the value of a naught. This is a naught and this is an. This is an. If you have any problem related to this numerical, please comment to my video. Step and again find the value of bn. Find the value of bn. Find the value of bn. This is bn equal to 1 by pi integration minus pi to pi. Put to given limit. Put to the given limit. This is a limit minus pi to pi into fx into sine nx dx. Now put the value of fx. You can write 1 upon pi integration minus pi to pi. Put the value of fx x plus x square sine nx dx. Now bn is equal to integrate of this function. You can write 1 by pi bracket. First of all, you can write x plus function x plus x square. Now integration of this function minus cos nx upon n. Now minus plus differential of this function x. The differential of x is 1 and x square is 2x. And integration of this function is sine nx upon n into n means n square. Now again you write this plus minus differential of this function equal to 2 and integration of this function is equal to cos nx upon n to the power 3. N to the power 3. Now minus plus. Now minus plus. Now put the limit minus pi to pi. Put the limit of this function. You can write 1 upon pi. The function of sin x will be 0. Now the two functions are vary minus to pi cos and this cos. You can write minus pi plus x square. Pi square upon n cos pi x plus 2 cos pi x upon n cube minus, put the limit of minus pi. You can write minus plus. This is minus pi plus pi square cos minus pi x upon n plus 2 cos minus pi x upon n cube. Now solve this function. You can write 1 by pi bracket. Now solve this function. This is cancelable value, and now again this minus pi. Now no minus minus plus minus pi. This means minus 2 pi upon n cos pi x. Now you can write. Now you can write minus 2 upon n minus 1 to the power n. This is a value of Bn. This is a value of Bn. You can write Bn is equal to minus 2 upon pi minus 1 to the power n. This is a value of Bn. This is a value of Bn. Now again find the value of B1, B2, B3 and so on. Now you can note down again this step. This is very important. Please you can remember the value of the coefficient value of Fourier coefficient value of A0, An and Bn. Step is by Fourier series fx is equal to A0 by 2 plus summation n equal to 1 to infinite an cos nx plus summation n equal to 1 to infinite bn sin nx. Now put the value of all, or you can also write a0 by 2 plus a1 cos x plus a2 cos 2x and so on plus an cos nx plus b1 sin x plus b2 sin 2x plus and so on plus bn sin nx. Put the all the value of a0, a1, a2 and an and b1, b2 and c2. You can write the value of fx, this means x plus x square is equal to the value of a0, this is equal to 2 pi square upon 2 into 3 plus the value of a1, this is equal to 4 bracket, put the value of a1 minus cos x plus the value of a2 cos 2x upon 2 to the power 2 minus a3 cos 3x upon 3 to the power 2 plus plus the value of bn. This is minus 2 upon 3. You can write minus 2 bracket, put the value of b1. This is equal to, if n equal to 1, you can write minus 1 upon 1. This means minus sin x plus sin 2x upon 2 minus sin 3x upon 3 plus and so on. Now this is a Fourier series function of a0 b a0 by 2 summation n equal to 1 to infinite an cos nx plus summation n equal to 1 to infinite bn sin nx. Now you can write this equation. You can write pi square by 3 plus 4 bracket minus cos x plus cos 2x by 2 to the power 2 minus cos 3x upon 3 to the power 2 plus plus you can write minus this, you can write minus sin x plus sin 2x upon 2 minus this. This is equation number first. Now putting x is equal to pi. X is equal to pi. Now you can write pi plus pi square is equal to pi square by 3 plus 4. Now put the value of pi. This is 1. This is 1 plus 1 by 2 to the power 2 plus 1 by 3 to the power 2 plus dot dot dot, and the value of this function is 0. This function is 0. Now you can write pi plus pi square is equal to pi square by 3 plus 4. Now my 1 plus 1 by 2 to the power 2 plus 1 by 3 to the power 2 plus dot dot dot. This is equation number 2. Now again x is equal to minus pi. You can write minus pi plus pi square is equal to pi square by 3 plus 4, 1 plus 1 by 2 to the power 2 plus 1 upon 3 to the power 2 plus dot dot dot. Now the value of sine function is 0. This is equation number 3. This is equation number 3. Now first of all you can note down all the steps of this function. If you have any problem related to this numerical and any step of the Fourier series function, please comment to my video, and please like and subscribe is also and promote to my channel Dual Mathematics. Now I am continue to the next step. First of all you can note down adding the equation second and fourth, adding equation second and third, you can write 2 pi square is equal to 2 pi square by 3 plus 8 bracket 1 plus 1 upon 2 to the power 2 plus 1 upon 3 to the power 2 plus 1 upon 4 to the power 2 plus dot dot. Now you can solve this numerical, this problem. You can write pi square minus pi square by 3 is equal to 4, 1 plus 1 upon 2 to the power 2 plus 1 upon 3 to the power 2 plus 1 upon 4 to the power 2 and so on. You can write 2 pi square upon 3 is equal to 4, 1 plus 1 upon 2 to the power 2 plus 1 upon 3 to the power 2 plus 1 upon 4 to the power 2 and so on. Now you can write pi square by 3 is equal to 2, 1 plus 1 upon 2 to the power 2 plus 1 upon 3 to the power 2 plus 1 upon 4 to the power 2 plus so on. Now you can write pi square by 6 is equal to 1 plus 1 upon 2 to the power 2 plus 1 upon 3 to the power 2 plus 1 upon 4 to the power 2 plus so on. Hence prove that. Or also you can write pi square by 6 is equal to summation n equal to 1 to infinite 1 upon n square. Hence prove that. This is a function of Fourier series problem. If you have any problem, please comment to my videos and please watch again to again. Find the value of Fourier series coefficient A0, An and Vn, and again find the value of A1, A2, A3 and so on. Similarly B1, B2, B3 and so on. Thank you for watching my video. Thank you.